All right, creationism versus evolution. We're looking at age dating methods, more specifically radiometric age dating methods, and even more specifically uranium and thorium, and how its decay rates can be quite erroneous by not assuming that what you see in a rock in the field, which contains lead, thorium, or lead, uranium, may not have a mother and daughter relationship entirely. The lead may be original lead. After all, lead, there is original lead. And if you don't know, and you can't know, you look at a rock, it's got 20 pounds of lead, 40 pounds of uranium. How many of the 20 pounds is actual mother-daughter? So you can figure out where you started with, and you can figure out what the decay rates are and how old that rock might be. And that's where we go from here. K53A.htm, original lead not considered. If original lead is not considered in radioactive age determinations, it leads to false conclusions, which can be considerable. A more important reason for the errors in the earlier published ages was the neglect of the factor of original lead in the mineral. Obviously, if some of the lead in the sample was not non-radiogenic, in other words, it's original, then the computed age would be much too large by an indefinite amount, unless the common lead were first determined and eliminated from the calculation. Recognition of supposed common original lead depends on detection of lead of atomic weight 204 in the mineral. Oral lead contains a small amount of this isotope along with the larger but varying amounts of 206, 7, and 8 atomic weights. Each of the latter isotopes can also be produced radiogenically. However, the all-important amount of lead 204 is quite difficult to determine accurately. As G. Tilton points out, it should be realized that the Pb204 abundance is the least accurately known of all the isotopic abundances for the leads. Dr. Patton notes, what complicates things for the uranium lead method is that non-radiogenic lead, 204, 206, 207, and 208, also exist naturally. Scientists are not sure what the ratios of non-radiogenic to radiogenic lead were early in the moon's history. The problem of how much, talking about what discovered, the problem of how much lead was around to begin with still remains. If all the lead age dating methods, rubidium, strontium, uranium, lead, and potassium argon, had yielded the same ages, the picture would be neat, but they haven't. The lead ages, for example, have been consistently older. Isotopic ages have been obtained for material from 5 landing sites on the moon, those of Apollos 11, 12, 14, and 16, Luna 16. Each site has a different age, but in a given site, the ages also vary. Ideally, however, only one basaltic rock from a given site should yield the same isotopic age, regardless of the method used. Just not acceptable information that we have today. We can't draw any conclusions. Leaching of lead or uranium results in radically incorrect age determinations. Other possible sources of error are known to exist, of course, and have been used as a basis for rejecting measurements which seemed incapable of harmony with the accepted chronology. Hahn indicates one possibility. Otto Hahn. It may be that part of the lead was leached out. Then the age determined would be too low. However, it also is possible that uranium was removed. Then relatively too much lead would be found. How do you know? You weren't there when the rock was there for millions of years or whatever, dozens, and the age determined would be too high. It follows that reliable lead values can be expected only from specially selected dense mineral samples that are weathered as little as possible. Even then, you don't know. Could have been a local flood that redeposited the lead into a secure place, but lead was around before that. The serious probability of significant uranium leakage is clearly shown by the following. Most igneous rocks also contain uranium in a form that is readily soluble in weak acids. A lot of weak acids out there in the earth. Hurley found that as much as 90% of the total radioactive elements of some granites could be removed by leaching the granulated rock with the weak acid. Larson and Fair note that commonly as much as 40% of the uranium in most fresh-appearing igneous rocks is readily leachable. Don't tell me it didn't rain occasionally. The seriousness of these defects is also pointed out by Fall. Countless determinations have been made by this method, but it was found that the premises on which the method rests, the control, are not valid for most uranium minerals. There is definite evidence of selective uranium leaching by acid waters, and now it is known that most radioactive minerals contain some lead when they were formed. As a result, that's original lead, most of the early, and for that matter all, of the lead-uranium age determinations are questionable. So much for that. Dr. Patton says the fourth assumption presupposes that the concentration of uranium in any specimen has remained constant over the specimen's life. Groundwater percolation can leach away a proportion of the uranium present in the rock crystals. The mobility of the uranium is such that as one part of a rock formation is being impoverished, another part can become abnormally enriched. Such changes can also take place at relatively low temperatures. Don't forget, a lot of these radioactive materials came from the center of the Earth or underneath the surface of the Earth through violent catastrophic events. So it might crack a rock in half, of which then the balance between lead and uranium is disturbed. And then you have rainfall, water floods, all kinds of disturbance, volcanic eruptions that mix and match all these rocks. And you get around looking at and get a rock like that. It's been around for, you think, millions of years. It's only been around for dozens. Methods which compensate for shortcomings in the lead age method fail completely. Again, Don Patton says there have been a number of very diligent efforts to try to overcome these limitations to the accumulation problem. Knowing how much there was to start with at the bottom, how much has leaked in and how much has leaked out. One of these methods involves the isochron method, the whole rock isochron method, using several different dates that are supposed to plot mathematically along a straight line. If they line up in a straight line, then we're supposed to know that this is an uncontaminated sample, nothing leaked out or leaked in. Well, the result is it just doesn't work. For example, in a recent example done by the Institute of Creation Research dating the lavas in the Grand Canyon, up at the top of the plateau which was tested, there are supposed young basalts or lavas that have formed over the lip of the canyon and down into the canyon and actually down the river in some places, obviously the youngest portion of a rock, flowing over the edge down into the river. However, down into the inner gorge in the metamorphic rock, we have the cardanous basalt, supposed to be among the oldest rocks in the canyon. And here we see a date that has been achieved at 1.07 billion years. And in an isochron has been done, it plots along the straight line, and that's supposed to tell us that there is no contamination. But we go up to the top where we have the very recent lavas that flow over the lip, and we find a date of 1.34 billion years compared to the one in the bottom, 1.07 billion. Now wait a minute. Here's the youngest older than what's supposed to be much older at the bottom. So the youngest is older, and the older is younger than the one at the top, which formed later. The stuff at the bottom is supposed to be oldest. And we do the whole rock isochron method on this date, and we find it plots in a straight line with 1.34 billions, supposedly very precisely. And yet, We know that cannot be so. Top of the canyon is younger than the older. When you get to the proof of the pudding, so to speak, then you find that it simply doesn't work. Science magazine recently, there was an article called Pseudo-Isochron. 30 examples were given of isochrons forming straight line that we know from the physical evidence is not dated accurately, where you have rocks that are interbedded, laid down necessarily at the same time, which give widely different dates by hundreds of millions of years, but all are next to each other, but all date on the isochron. So their method says, oh yeah, this is a good one, but they're next to each other. How could they be billions of years older than the other? Yet the system of trying to determine those beginning conditions then just doesn't work. What actually happens is illustrated in the quote by Richard Mulliger from the Department of Geology at East Carolina University in Contributions to Geology. He says, in general, dates in the correct ballpark are assumed to be correct and are published, but those in disagreement with the other data are seldom published, nor are the discrepancies fully explained. Interesting. But what are you looking for? This is what I'm looking for. Okay, let's just keep doing measurements till we get it. You're going to get it because they vary all over the place. Now, this is how it works. You keep what fits, you chuck what doesn't fit in your belief system. You unjudiciously select if you please. So, lead isotope methods are not accurate either. So we have lead isotopes. Another method consists of comparing the relative amounts of the two lead isotopes, 206 and 207, which are present in the mineral. Actually, the method is subject to several errors. Loss of radon, 222, raises the lead ratio and the calculated age. A rather large error may be introduced by the uncertainty in the composition of the original lead. This error may exceed the measured value when dealing with younger uranium minerals containing even small amounts of original lead, as clearly recognized by Holmes when the method was approved. It is common now to attempt to allow for contamination by original common lead by assuming without actual proof that the presence of lead 204 in the mineral indicates such contamination. The presence of old radiogenic lead formed in a prior site of the parent uranium may also cause great error. Many or most such minerals might equally well contain some contaminating radiogenic lead from some other source. If so, the age computation would of course be too high by a quite unknown amount. The possibility of this type of phenomenon occurring is indicated by a recent study of the University of Toronto. There are some leads that have been referred to as anomalous, which have isotope ratios that do not, at first sight, seem to participate in this regularity. We believe that additional amounts of radiogenic lead have been added to these leads at or about the time of final mineralization. That is, an anomalous lead is simply an ordinary or non-anomalous lead which has been further altered. You don't know whether it's been intact, the sample that you're measuring, and it could be off by millions of years. The above authors, Farquhar and Fussell, were concerned about the fact that too much radiogenic lead was present in certain supposedly ancient lead ores to harmonize with the false theory that common lead has been uniformly enriched during geologic time with increments of radiogenic lead, as experienced by the larger proportion of lead isotope 204 in older common leads. These anomalous, so-called abnormal leads show that less 204 lead than should be present according to the theory. The really significant thing, however, is that it is thereby evident that radiogenic lead can contaminate any uranium lead-bearing mineral to an unknown amount, and that thereby make any age determination on it meaningless. Just have no idea, up or down what. That such contamination of ordinary lead deposits by radiogenic lead is far from rare is indicated by the following. True ordinary leads are probably derived from below the crust, and anomalous leads are derived in turn from these by variable radiogenic contamination in the crust, which you don't know, you weren't there. Thus, ordinary and anomalous leads form a series of rather than two distinct groups. It is likely, furthermore, that no absolutely ordinary leads occur on the Earth's surface, and all have probably received at least minute radiogenic contamination in coming from the mantle. That's where they really were, and the violent catastrophic things, or according to them, millions of years can go by. You say nothing really disturbed anything. Really, were you there? The ratio of the lead isotopes in deriving